basically what you want to do is you want to just evaluate this limit when they ask for a horizontal asymptote. X goes to infinity. Which of the following is a horizontal asymptote? Yeah, 2x plus 5 over e to the x plus 1. And it's only going towards positive infinity because the function is defined for positive x values. So now here, this limit, right? What you notice is that as x gets larger and larger, the top part gets larger and larger, and the bottom part gets larger and larger. So that means that it's in the form infinity over infinity. And this meets the requirement for it to be possible for you to do L'Hopital's rule, which is that this limit will be equal to the limit as x goes to infinity of differentiate the top. Don't do quotient rule. Differentiate the top. You're going to get the derivative of 2 to the x is ln of 2 times 2 to the x. Plus the derivative of 5 is just 0 over the derivative of e to the x is just e to the x, and then the derivative of 1 is just 0. So now I have this is going to be multiplied. I could pull out the constant, the ln 2, times limit as x goes to infinity of 2 to the x over e to the x. And we should see that this is going to be the same thing as the limit as x goes to infinity of 2 over e, all of it, to the x. Now, the key thing with now evaluating this limit is this following fact. So the limit as x goes to infinity for, let's say, a to the x, right? Well, if a is between 0 and 1, let's investigate what's happening here. So let's say a is a half, right? What's happening? Limit x goes to infinity 1 over 2. Right? This is going to be continual multiplication by a half. So it's going to be 1 half times 1 half, which is a fourth. And then times a half, which is an eighth. Right? And as you keep multiplying halves, these values get smaller and smaller or closer to 0. And that's if a is between 0 and 1. And if you look here, e is like a little bit more than 2 or somewhere between 2 and 3, but it's greater than 2. So this value is less than 1. It's 2 to the e, but it is for sure greater than 0, but that doesn't matter because this limit as a whole, as long as it is that it's between, this value on the inside is between 0 and 1, the limit as x goes to infinity of it is going to tend towards 0. And then this is going to just tend towards 0, and your answer is 0. That is the horizontal asymptote.